Okay, so we're going to talk about average atomic mass. In order to do this, first we should define what an average is. An average is the sum of two or more quantities divided by the number of quantities. So if you think about taking tests, let's say you took 4 tests. On the first test you score 90, the second test you score an 80, third test you score 100, and the fourth test you score 75. To get the average, you would add those numbers together and you get 345, and then you would divide that by 4. That's the number of quantities or the number of tests that you took. So 345 divided by 4 is 86.25. So your average on those 4 tests is 86.25. Now that's just a standard average. There's another way to get an average, and it's called a weighted average. And a weighted average is an average in which a quantity is assigned to each weight. Or a quantity is assigned a weight, okay, or relative importance. So if we take the same 4 test scores, and what we do is we assign a percentage value for each of those. 20% for the first test, 20% for the second test, 20% for the third test, and 40% for the fourth test. We've assigned a weight to each test. Now, to get the weighted average, what we do is we multiply the score on the test times the percentage that it's worth. Okay, and so if we take 90 and we multiply times 0.2, because 0.2 is 20%, add that to 80 times 0.2, add that to 100 times 0.2, and add that to 75 times 0.4, we get 18 plus 16 plus 20 plus 30, which gives us an 84. That's a weighted average. It's lower than the normal average because the last test was worth more and you scored the lowest on that value. Okay, so a weighted average takes into account the percentage or the importance of that individual component. Now, a average atomic mass that we find on the periodic table is a weighted average. So here we have a periodic table, and on this periodic table there is the listing of the mass. So what I'm going to do is blow up neon and circle the average atomic mass for neon, and this average atomic mass value here, this is a weighted average. So I'm going to show you how we calculate that. We have isotopes of neon, and there are 3 stable isotopes for neon. Each has a certain percent abundance and a mass. You have 2010 neon, which is 90.48% of all the neon atoms are neon 20. That has a mass of 19.99. 21 neon, or neon 21, 0.27% of all the isotopes out there, neon atoms are neon 21. They have a mass of 20.99. You have 2210 neon, which makes up 9.25% of all the isotopes of neon. Then their mass is 21.99. So what we want to do is we want to multiply the percent abundance for each isotope times the mass of each isotope and then add those values together. If you do that, what you'll get is 0.9048 times 19.99 plus 0.0027 times 20.99 plus 0.0925 times 21.99, which will give you, when you add up those numbers, 20.18 as the value, which you see matches the number on the periodic table. That's how we calculate an average atomic mass.